My name is Ouday Taweel. I am a design engineer here at Magnet. Design engineers are important to manufacturing because they not only help you make a better product, but they help you make a more cost-effective product, a more easy-to-produce product. A design engineer is somebody that brings ideas into the real world, whether it be from drawings, 3D models, and actual physical objects, bringing it from just an idea to something that you can make and make sure it works. Magnet is a company in Cleveland, Ohio that helps small to medium-sized manufacturers with whatever issues they may have, such as optimization of their processes, making it so they can make more parts, do things more efficiently. We help with making prototypes of people's products. Entrepreneurs, if they come to us with an idea, we help them get prototypes using stuff like our 3D printers to just get them something in their hands so they can see how it works. We hold classes here for high school students and for adults just to get people back into manufacturing. And we also have schools taking field trips over here, middle school, elementary schools, to get them exposed to manufacturing, automation, which is what most of these machines are used for. The biggest tool to help me design things is CAD, which is computer-aided design. It's a software where you model things in the third dimension. You make the part. Instead of just a drawing, it's the actual physical part. And that's the first step in making it into the real world, because you're not going to be able to take a drawing and just get that to a 3D printer or get that into a CNC. You need to have the part to be able to bring it into the real world, bring it into real life. And it's also important because you can see if your thing is actually going to work, if your part's going to work. See how things fit together, if anything's going to interfere. It gives you a really good visual representation of what your design is going to look like, and it saves a lot of hassle in the long run. So here's an example of a 3D design, and this is the car assembly machine. So that entire machine is made digitally, like on the computer. It has the robots, 2 robots. You can see the frame. Some hardware too. This helps you get counts for how many screws you need to buy, what kind of screws you need to buy. Makes that a lot easier. It's cool to see it from going to the computer to being able to hold it. Like a lot of people in engineering talk about that. Being able to make something on your computer and then within a couple of hours have it in your hand. It's cool. It's 2 completely different spectrums of engineering, but you need both of them to get the full experience. So we want to get people experiencing manufacturing, but not only the technical stuff, but the other parts you don't think of. So with the car assembly robot, we have them pick each part and they scan it almost like they're in a store. So they have a budget. They need to kind of optimize everything to make sure they're not spending too much, but they want to make sure their product works. They have to pick the right parts, which kind of shows them the design aspect of it. And then they get to load those parts into the robot, and the robot will assemble it for them. And then their goal is to load their car with the most weight and get it up a ramp. And it's only based on getting up to the ramp. It's not based on speed. So they just have to get their car to the end of the ramp with the most weight. As they're picking their parts, they scan this, and they each have a cost, so you have to keep budget in mind. The first part has a code, so their car gets transferred through all the machines to make sure that they keep track of it, and then when they put weights on it and stuff, it'll be associated with the car, with the cost. It gives you that assembly line feel, but it also gives you that speccing something out and incorporating cost into it, because there's 2 different kinds of motors. This one is weaker, but it goes faster. This one is stronger, but it goes slower. They have different costs, so thinking if that trade-off is worth the cost difference is what they get to consider as they're making it. You scan the parts as you grab them, so that's the motor. Here are the wheels. Axle clips. Some of these things are required, so you have to include them in your design. There's a picture here for reference, so they know how to set up the tray for the robot, because the robot's going to be putting the car together. You take it over to our robot friends. Robot friends, because there's 2 robots in here. This drawer will open, and then they place it. There are some pictures kind of spread out around here so they know, make sure everything's oriented properly. That's good. This magazine also gets put in there with all the axle clips. Drawer closes, and then the machine will say, load parts into tray, press next after the car parts are placed in the loading tray. They are. So you hit next, and then it says ready to start, press start to begin. So press start. Robot's gonna take a picture of the tray, so it's gonna know where everything is. You'll see the red flash, and it starts grabbing things in the order that we specified. And you'll see here, it'll scan the QR code. So now the robot knows what car it has and how much the cost is. It's trying to scan it, and of course it's not. Oh, there it is. And this is what you get out of the robot. So it put on those clips, it screwed the wheels onto the axles, installed the motor. You place the car here, that scans it, QR code, so now the machine knows what car is here. We vacuum form car bodies, and they decorate them and take them home. And they get to experience a side of manufacturing which most people don't know about, which is vacuum forming. Pull that up, and then that's pulling the air out, wrapping around. Whoosh. Okay, I let it sit for a sec because it's still a little bit soft, and then this will push air into it, and you do that as you lift it down. And the car's stuck in there, so you just give it a little tap, and there it is. That gets cut out, and then the students get to decorate them and take it home. So you see the grill, you get to see the windows. I would tell my 10-year-old self to look forward to being able to make things, being able to take your ideas that you thought of and being able to bring it into the real world. Because I was very imaginative as a child, and having the ability now to, if I think of something, to be able to make it is huge for me. And I think my 10-year-old self would go crazy over that. I love working here because I get to do something different every single day. There's so much to do here, a lot of hands-on stuff, a lot of computer work, and being able to get like a well-rounded manufacturing experience was really important to me when I was looking for a job. So that's why I love it here. There's just so many different things to do, so many different people to work with, and it makes me like excited to come into work every day. I don't feel like I'm working, and that's what I want out of a job. I don't want to feel like I'm working. I want to feel like I'm learning and enjoying myself.